Hello everyone and welcome to this video. In this video, we're going to talk about speed time graph. As you can see here, this is a speed time graph. On the vertical axis, you have speed. On the horizontal one, you have time. So this speed here is in meters per second and the time is in seconds. Now let's solve these questions so we understand the ideas. This one is already solved. Yes. Yeah, this one is already solved. So let's take a look at other question so we can answer it, okay? Let's take this one, for example, here. Or let's take one that has a trapezium because it's more likely to come. First, this is the speed in meters per second, time is in seconds. First thing we do, we read the question carefully and understand what they need from us, okay? Let me cover these spaces so we can work on them. I need the space to write the numbers and the formulas. Cover this, that. Okay, so speed time graph. First question, a speed time graph is shown for the journey of a train between two stations. Find the acceleration over the first 40 seconds in meters second square. Now, first thing you need to know that acceleration has a formula by its own. Acceleration equals speed over time. Speed over time. Now, if you find the speed using the graph and the time using the graph, and you divide them by each other, you'll get the acceleration. Now, when we talk about acceleration, it's the same thing when we talk about deceleration or retardation. It's the same idea, same formula, but it's in the opposite direction. That's the whole idea. So, acceleration and deceleration or retardation are in the opposite direction. So, when you look at the graph here, this line here that's going up, this is acceleration. It means it's increasing speed. This one is constant speed, the horizontal line. And this line here, which is going down, we call it retardation or deceleration. Now, let's check the first question here. Find the acceleration over the first 40 seconds in meters per second square. So this one is the 40 seconds, the first 40 seconds. To find the acceleration, we have to find the speed. The speed is 80. Very good. So basically, I'm going to use this formula. Acceleration equals speed over time. Speed is 80, and the time is 40 seconds. So I have to divide 80 divide 40. Okay, 80 divide 40. And the answer is 2 meters per second square. 2 meters per second square. So by this way, I found the acceleration over the 40 or the first 40 seconds. So I'll write it here. This is the first answer, 2 meters per second square. Now for the second question, find the retardation over the final 80 seconds. So over the final 80 seconds, it means the last 80 seconds from here till here. So this line here. First thing, I have to find the speed. The speed is 80. And then I want to find the time. The time is the last 80 seconds. So the speed is 80 and the time is 80. And then I want to divide the speed over the time. So 80 divide 80. And the answer is 1. So the answer is 1 meters per second square. So yeah, yes. So 2 meters per second square, this is the retardation over the last 80 seconds. Now, this question is good. It's done. Let's write the answer next to it. Now, the second question, or question C, just per second square, find the total distance traveled in meters. The total distance in speed time graph is what? It's the area under the graph. It means you look at the shape here. You can see that this is a trapezium. If you find the area of this shape, this is the distance traveled in meters. Okay, this is the distance traveled in meters. This means that if I find the area, I have found the distance. Now, we know that the shape is a trapezium, and we know the formula of the area of the trapezium. Let's write the formula here. The trapezium area, let's call it A, or area, equals A plus B, A plus B divided by 2, like this, and then multiplied by the height, multiplied by the height times the height. Okay, so a plus b divided 2 multiplied by the height. Now, what is a and what is b? And can I use other formulas to find the area of the shape? Yes, you can find it by dividing the shape into two triangles and a rectangle. Find the area of triangles by using the formula, which is half base times height, half base times height, and the area of the rectangle will be the length times the width. Or use the formula of the trapezium directly to find the area under the graph. So I'm going to use this area of trapezium directly instead of using or separating the shape. Now, this is the whole shape. First, you need to understand that this long line is called the long base, which is the B. So the B here is 160. B is 160. So I'm going to write it here. So B equals first A. A is the one on top, the short base, which is 40, from 40 till 80. So A is 40. B, as we said, is 160 because it's the long base here. And the height is 80. Height is 80. So H equals 80. Now I have the numbers that I need to substitute inside the formula. Now I'll use them here. So A plus B, 40 plus 160, divided by 2, and then multiplied by height, which is 80, multiplied by 80. And I'll get the answer for the area under the graph. So here, I'll use a calculator to do this. Or basically, 40 plus 160 is 200. 200 divide 2 is 100. 100 times 80 is 8,000. So 100 times 80 is 8,000. And this is the area under the graph. To make sure, I can use the calculator. 40 plus 160, sorry, and then divide 2, it's 100, and then times 80 is 8,000. And it's 8,000 meters, or because it's a distance, I'm going to call it meters. But basically, the area is meters squared. And this is how you find the total distance traveled in meters. So this one is 8,000 meters. Now, the last question will ask me about the speed of the journey, or the average speed of the journey in meters per second. So basically, I know the distance, I know the total time, I can find the speed, because speed will equal what? Very good. Speed will equal distance over time. Speed will equal distance over time. Now I'm going to use this formula to find the speed by using the distance that I found at the beginning, like this. I'll put equals, yes. Because speed equals distance over time. The distance is 8,000 and the time is 160. So I'm going to divide them by each other. So 8,000, sorry, divide 160. And by that, I will find the speed of the whole journey equals. So 8,000 divide 160. And the answer is 50. And this one is meters and this one is seconds. So meters per second. And that's the whole idea of this question. So the answer is 50 meters per second. I hope you understood the idea of this question. It's so easy once you focus on the steps and the formulas that you have to use. Focus on acceleration and retardation. Focus on how to get the area under the graph, which is equal to the distance. And focus on finding the speed, which is distance divide time. That's it for this question. Thank you very much for watching. See you next time.